Today we will see the problem number 5 and 6 on the spur gears. So let us start with the problem number 5. The following are the particulars of a single reduction spur gear. The gear ratio is 10:1 and the center distance is 275 mm. The pinion transmits 375 kW at 1800 rpm. The teeth are of involute form with standard addendum of one module and pressure is 22.5 degrees. The normal tooth pressure not to exceed 9810 Newton per centimeter width. Find the first one, the nearest standard diameter pitch if no interference is to occur. Second one, the number of teeth in each wheel. So this is the given problem. In the given problem, the two parameters what they have asked to find: the nearest standard diameter pitch if no interference is to occur. To find this data, first we have to find the number of teeth on pinion and gear to avoid the interference. That is the same thing what they have asked in the second one, the number of teeth in each wheel. So in the problem number, in the bit number 1 only, we get the solution for bit 2 also. So first we have to find number of teeth to avoid interference on pinion and gear, both the wheels. With the help of that, we can find the nearest standard diameter pitch if no interference is to occur. So this is how the solution is related for bit 1 and bit 2. Now if we look into the given data, the gear ratio is given 10:1. So that is gear ratio G is 10. Center distance is given as 275 mm. Power transmitted is 375 kW. Pinion rotates at 1800 rpm. The standard addendum is one module they have given, so addendum is equal to one module. Pressure angle is given as 22.5 degree, and we'll see whether this data, that is the normal pressure not to exceed 9810 Newton per centimeter width, whether it is going to help us or not. We'll check this one. So here we know that addendum is equal to addendum constant into the module. In the problem it is given that one module is equal to addendum constant into the module. So here the module will get cancelled and we get addendum constant as 1. So addendum constant is equal to 1. Next we know the equation for a minimum number of teeth on pinion to avoid interference. Small t is equal to 2 into addendum constant divided by 1 plus 1 divided by g sin square phi into 1 divided by g plus 2 whole raised to 1 by 2 minus 1 into g. So this is the equation for finding the minimum number of teeth on pinion to avoid interference. We'll substitute the parameters one by one in this equation. So small t is equal to 2 into addendum constant is the 1, so we'll put it as 1, 2 into 1 divided by 1 plus 1 by 10. The gear ratio G value we have 10, which is given in the question. 1 by 10 sin square phi value, that is the pressure angle, it is given in the question as 22.5 degree. So 22.5 into 1 by G plus 2 whole raised to 1 by 10 minus 1 into G, that is 10. So after calculating this value, we get number of teeth on the pinion as 13.1058. Therefore, we can say the minimum number of teeth on pinion is 14. Just round off into the next value, so 14. Therefore, we can say minimum number of teeth on gear is 14 into 10, that is the gear ratio value, because gear ratio is capital T by small t, and when the small t is known to us, so for finding capital T it is G into small t. So we get 14 into 10 as 140. So 140 is the minimum number of teeth required on the gear to avoid interference. After knowing the minimum number of teeth required to avoid interference on pinion and gear, next we have to find the nearest standard pitch circle of pinion and gear. First we start with standard pitch circle of pinion, which is given by small r is equal to module into number of teeth on pinion divided by 2. So number of teeth on the pinion we have 14. So here we get 7m, that is module. 7 into module, 7 times the module is the standard pitch circle of pinion. Similarly, standard pitch circle of gear is given by capital R is equal to m is means module into number of teeth on gear divided by 2. Here number of teeth on the gear we have 140. So we get 70 into module, that is 70 times the module is the pitch circle of gear. Therefore, we can write center distance C is equal to pitch circle radius of pinion plus pitch circle radius of gear. So substituting the values, center distance in the question it is given as 275 is equal to small r value we have 7m, capital R value we have 70m. Substituting that, we get module as 3.57 millimeter. So after this we have to check for the standard module value, and we know that the next standard module value is 4 mm. So selecting standard module as 4 mm, we'll next see correct center distance. Correct center distance is given by module into 77 is the correct center distance. So module is 4 mm into 77. After that we get correct center distance as 308 millimeter. Therefore, nearest standard pitch circle of pinion can be written as small d is equal to 2 into r, where r value is the standard pitch circle of pinion, which we have calculated as 7 times the module. So 2 into r value as 7 times the module. Here we know the module value as 4. So here it is 2 into 7 into 4. 56 mm is the nearest standard pitch circle of pinion. Similarly, nearest standard pitch circle of gear, capital D is equal to 2 times the capital R, where capital R is the standard pitch circle of gear. Capital R is given by 70 times the module, that is 70 into module. So here we can write 2 into 70 into module as 4 we have calculated. So here we get nearest standard pitch circle of gear as 560 mm. So this is the solution for the given problem. Next we have problem number 6. The standard full depth 14.5 degree gear have a module of 5 mm. The pinion has 15 teeth and the gear has 60 teeth. Addendum is equal to 1 module. First one, show that the gear will interfere with pinion. Second one, should the pressure angle be increased to eliminate interference? So this is the given question here. There are 2 bits in the given question. In the first bit they have asked us to show that gear will interfere with the pinion. So we have to find minimum number of teeth to avoid the interference on the pinion, because they have given the pinion or the gear, and we can see that if it is found that minimum number of teeth on pinion and gear to avoid interference is more than the given, then it can be proved as gear will interfere with the pinion. Next, by keeping the same number of teeth on pinion and gear, that is 15 and 60, whether by changing the pressure angle, that is by increasing the pressure angle, can we eliminate the interference? That we have to see. So let us start with the given data. It is given that pressure angle is 14.5, module is 5 mm, number of teeth on pinion is 15, number of teeth on gear is 60, addendum is equal to 1 module, and it is given module is 5 mm. So addendum is equal to 1 into 5, that is 5 mm. So addendum is also 5 and module is also 5 mm. Next we have addendum is equal to addendum constant into the module. So this is the known to us. Substituting the value of addendum and module, we come to know that addendum constant is equal to 1. Next, minimum number of teeth on pinion to avoid interference. So this is the equation what we know for a minimum number of teeth for on pinion to avoid interference. Small t is equal to 2 into AW, that is the addendum constant, divided by 1 plus 1 by g sin square phi into 1 divided by g plus 2 whole raised to 1 by 2 minus 1 into gear ratio g. Here they have given the value of gear teeth as 60 and number of teeth on the pinion as 15. So we know that gear ratio is ratio of capital T by small t. So 60 divided by 15, we get value of g as 4. Substituting these parameters in this equation, we get small t is equal to 2 into 1, because addendum constant is 1, divided by 1 plus 1 by g. Value of g is 4. So sin square into phi. Phi, the pressure angle value we have 14.5 degree. So it is 14.5 into 1 by g is 1 by 4 plus 2 whole raised to 1 by 2 minus 1 into g as 4. So substituting all these parameters in the equation, we have calculated minimum number of teeth on pinion to avoid interference is 28.6. So we can round off this to next value as 29. Since in the given question we know that number of teeth on pinion is 15, which is less than the 29, that is minimum number of teeth on pinion to avoid interference is 29, but what is given as 15. So with this we can conclude that interference will occur between the pinion and gear. So this is the solution for the first bit. We have proved that interference will occur between pinion and gear. Now in the second bit we should check whether by increasing the pressure angle can we eliminate, or by increasing how much angle we can eliminate the interference. That we have to check. So let us see for the second bit. So here we have the second bit. Should the pressure angle be increased to eliminate the interference? That we have to check. So when we have number of teeth on pinion as 15, that is the given. So in this condition, so what should be the pressure angle phi to avoid the interference? That we have to check. So substituting the parameters in the equation which is used for finding the number of teeth on the pinion to avoid the interference, small t is equal to, that is 15 is equal to 2 into AW, that is the addendum constant is 1 divided by 1 plus 1 by g. G is gear ratio value 4 sin square phi. This phi we have to find in this equation into 1 by g. G value is again 4, the gear ratio, plus 2 whole raised to 1 by 2 minus 1 into the gear ratio g, that is 4. So in this equation only unknown is the pressure angle phi. So when you calculate it for pressure angle phi, you will get pressure angle phi as 20.3114 degree. Therefore we can say that pressure angle should be increased to 20.3114 degree. The given pressure angle in the question is 14.5 degree. So from 14.5 degree to we have to increase it for 20.3114 degree. So to eliminate the interference when number of teeth on pinion is 15 and gear is 60, we have to increase the pressure angle from 14.5 degree to 20.3114 degree. So this is the solution for the given problem.